Hi everyone and welcome to the Microsoft Fabric UK user group. I'm your host Leon Gordon, and as always we're back for another fantastic session on all things Fabric. Now please do let us know as always where in the world you're joining us from. If you're like us in the UK and in parts of Europe, it's an absolute heat wave. So thank you very much for joining us, and I hope you're all comfortable wherever you are joining us from. As I mentioned, we have a fantastic session today. We're going to be looking at transitioning from data analyst to data engineer with fellow MVP Nikola Ilic. Now, it is an absolute treat for you all today because this is the first time that this session has actually been delivered outside of FabCon. So please support me in welcoming today's speaker, Nikola. Hi, Nikola. How are you doing?
Hey, hi, Leon. It's great to see you. Yeah, I'm doing well. Thanks. And yeah, thanks for having me. It's always a pleasure to present for your user group. I think it's my third time, if I'm not mistaken.
It is. You're becoming
a
regular.
But it's been a while. It's been a while. Yeah, it's been a while. Always happy to join you, of course.
Oh, fantastic. And thank you for bringing such a great session to us today. Without any further ado, Nikola, let's dive straight in.
Sure, thanks. And first of all, hi everyone, and welcome from my side. Good morning, good evening, or good afternoon, depending from which part of the planet you are currently joining. I see Fernando, hi my friend, is joining. We are a little bit jealous for these 23 degrees right now that you have in Mexico. Yeah, as Lev mentioned, we are here like in the oven. But yeah, let's talk about Fabric. And before we start, as Leon mentioned, this is the session that Thomas LeBlanc and I created specifically for FabCon Atlanta in March this year. This is a joint session from two of us, and we delivered it together. And it received a very positive feedback from the people over there. We had like 500 people in the audience and some great questions, some great comments. So I'm happy to be able to deliver it here, although without Thomas this time. But yeah, we'll see in the future if we'll join forces together. So how we came up with the idea about this session? Essentially, the idea is that we wanted to structure a session in a way that every Power BI professional who looked at Fabric notebooks and thought, "Oh no, that's not for me." We tried to show that, oh yeah, it absolutely is for you, and that your M skills, your Power Query skills, are more transferable to Fabric notebooks than you think. This is a teaser about this session, a brief introduction about myself. My name is Nikola. I'm originally from Belgrade, but for the last 10 years, I live in the wonderful city of Salzburg in Austria. Currently working as a principal architect for iLink Digital, one of the biggest Microsoft's global partners, helping customers to implement and migrate to Microsoft Fabric. You can find me on web. I'm blogging at data-mozart.com. Also co-authored 2 books for O'Reilly, Fundamentals of Microsoft Fabric with Ben Weissman, and another one which is almost done, Analytics Engineering with Fabric and Power BI. Privately, father of 2 kids and true football and Barca fan. Leon and I were just discussing about the World Cup before we went live. So yeah. Okay, so what's on our agenda for today? We will start with the bridge. So when to reach for notebooks versus staying in data flows, then different types of connections, Spark Engine basics, some common transformations, comparison side by side, optimization techniques like V-order, destinations, incremental loading, and takeaways. Heavy on demos, I need to stress this. There will be just a couple of slides, but most of the session is demo. I really want to show you how your skills, how your current Power Query skills can be easily transferred to using Fabric Notebook. So let's quickly go. And of course, I didn't mention, but of course, if you have any questions during the session, don't hesitate to ask. I'll do my best to provide the answer, and very open to discussion and very open to hear what are other people's thoughts on this particular topic. Now, to set the proper context for the rest of this session, I'm not going to tell you that data flows are bad and that notebooks are great. On the opposite, I want to show you what are the use cases for each of these two, and in which circumstances it makes sense to think about notebooks as the first solution, primary solution, and what are the constraints that you have when you're working with data flows, and these constraints doesn't exist with notebooks, or vice versa. So what can be easier done in data flows compared to notebooks. So to start, data flows are a great solution for low code ingestion, Power Query transformations, and incremental refresh, which all of these things you can configure in the user interface. But they have some hard limitations. For example, incremental refresh uses bucket level replace, not row level upsert. I will show you the difference later in a demo. You can't run some optimization commands on top of the tables while you are creating them, whereas notebooks unlock all of these possibilities. So through row level merge operation through the Delta Lake for any data source, and plus you can optimize your ingestion process using different techniques that we are also going to examine today. So the message, the first and most important message, and I will also close the session with this message, is not abandon data flows. It's just know when each of these tools fits into a specific scenario. Now, when we talk about connections and how you can bring the data into Microsoft Fabric, there are multiple ways to do that. Some of the low-code solutions that we have at our disposal, first is mirroring, where essentially we can connect to a bunch of different databases. In this example, it's Azure SQL database that is mentioned here, also in the screenshot as well. And with with mirroring in Fabric, we can essentially create a copy of the data in real time or near real time copy of the source data inside of Microsoft Fabric. So mirroring is a no ETL approach for bringing data into Fabric. This is a huge difference compared to data flows, where the emphasis is on the capability of doing different types of transformations while you are loading the data into Microsoft Fabric. So to give you just a quick example, if you are moving data from Azure SQL database and you want this data to be available as fast as possible inside Fabric without applying any additional transformations, you will probably take mirroring route. Whereas if you need to perform some transformations, then in that case, data flows is the better choice. When you use data flows, by default, what is going to happen is that, and maybe some of you already noticed this inside Fabric Workspace, there will be some additional items that by default should be hidden, but sometimes they are not. And these are called staging lakehouse and staging warehouse. We are going to talk about this capability and how the data flow works under the hood. But essentially, whenever you use data flows, by default, there will be some in-between steps that Fabric creates in the background to support these heavy transformations that users perform on top of their data. After mirroring and after data flow, the next option to load the data is copy job. Again, graphical user interface, no code solution. It's more flexible than mirroring because it allows you to configure the way the data will be copied. So you can use change data capture mechanism, incremental refresh, and similar like this. And of course, there are other options. So copy activity inside the pipeline, which is very similar to copy job, but it's more lightweight, let's say, and it's more convenient for as part of the bigger orchestration process where Fabric pipelines are the best option, obviously. For real-time streaming, we use event streams commonly. And finally, we have notebooks as a code-first approach for data ingestion and data transformation. So these are the options that exist inside Fabric. Why we are talking about these options? Most of them are more flexible than data flows, and most of them don't require these additional objects to be created in the background. And in terms of monitoring and having an influence on the data ingestion process, these options, especially notebooks, are more flexible than data flows. Before we start comparing data flows and notebooks, we need to take one step back, because notebooks are leveraging Spark engine inside Microsoft Fabric. So just a brief introduction about Spark engine without going deep into technical details, because that's outside of the scope of the session today. So when you open the notebook, by default, the notebook will and when you execute the first code cell inside the notebook, it will spin up the new session, the new Spark session. And this new Spark session, if you are using default settings in Fabric, will usually start in a couple of seconds. It's about 5 to 10 seconds. So you open a notebook and you go. If you create a custom environment, so you want to additionally configure settings for the execution of the notebook, then in this case, it may happen that the notebook, that the Spark session require a longer time to start, because in that case, there are no pools that are already provisioned in advance. One thing to watch here, check the Fabric Capacity Metrics app to monitor your consumption, so that Spark notebooks, typically they are consuming fewer capacity units than data flows for equivalent workloads. And I think it's important. One of the key advantages of notebooks over data flows is more efficient consumption of capacity units. Of course, there will be some cases where data flow performs better. It's workload dependent, but generally speaking, notebooks in most cases consume less resources than data flows. So this is how it looks like when you open the notebook. Take a look in the top ribbon. If you see the standard session, that means that you are using standard default settings for your Spark environment. And then session usually starts, as I said, very quickly. So in just a couple of seconds. So quick orientation on where notebooks fit in the medallion design pattern, because we are going to talk about transforming data throughout the session. First, bronze is your staging layer. So raw data lands there. Then silver is where transformations happen. And this is where notebooks really shine. This is the biggest strength of notebooks is when you are performing different data transformation operations. So data cleansing, typecasting, deduplication, things that I will show you in a demo in just a couple of moments. And gold as a serving layer. So star schema, dimensions, facts, typically in a warehouse, although it can be also a lakehouse. And today's demos, everything that I'm going to show you today is focusing on the bronze to silver transition, because that's where the data analyst's transformation skills translate most directly. Okay, so it's time to show the first series of demos. And I will start with simple transformations. I would say these are the transformations that every Power Query user knows. Split columns, extract before and after delimiter, replacing values, merging, appending queries, pivot and unpivot transformations. Now, you already know the what. We are about to show you how to do this in Spark, in PySpark, and then you will see it's the same logic, slightly different syntax. So let me open my Fabric environment. And before we start, just a quick intro of what we have here. I've created a lakehouse. Let me show you. It has 3 tables: bronze customers, bronze orders, and bronze products. I also have some files. So these 3 files, customers, orders, and products, were used to create these existing tables. I did that in advance, so we save some time for the session. And I also have 2 additional files that I will use throughout these demos to show you how to perform some of these transformations using a notebook. So this is a very simple scenario. So three bronze tables, 3 delta tables already in the lakehouse. Let me now go and open my notebook. Probably one of the questions will be, can we get these resources from the session? Absolutely, yes. So it's on my GitHub. You can go there and download. The entire notebook is there. All the files are there, so you can just load this into your lakehouse and feel free to play around. Okay, let's remove these things and let's start our session. So as you can see, I'm currently using a default settings, and currently I'm in the standard Spark session. So this can be changed if I want to use high concurrency and so on, or if I want to change the environment. But let's keep things simple. You saw that the session started in 5 seconds. It's time to see what we are going to do inside of this notebook. So first of all, I want to load all 5 CSV files from the Lakehouse files into Spark data frames and then write them as delta tables in the Lakehouse. For those of you who may not know, data frame is a temporary structure that exists inside of Microsoft Fabric, inside of Spark session, and it's active as long as your Spark session is active. So when your Spark session is disconnected or canceled or whatever, your data frames are gone. I'm telling this because I learned that harder way. Sometimes you play around, you think you persisted the data, then you go to grab a coffee, and when you're back, the session is disconnected and all your transformations, your temporary transformations are gone. So please bear in mind that data frames are temporary structure. So let's load the data from CSV files into data frames. So for each table, I have a separate data frame: orders, customers, products, new and wide. You see the number of rows and number of columns from each file that is loaded into a data frame. So I can't tell it's loaded in a table because it's still not. It's still just in a data frame. We can inspect quickly our schema, find if there are any problematic columns and similar. So kind of a data profiling equivalent that you do in data flows. And finally, let's write these 3 base data frames as delta tables. So basically, I'll just overwrite the existing tables just to show you how this works. And then we jump straight into transformations in these simple common transformations. So let's wait for a couple of more seconds. This is a live demo, so fingers crossed and praying to demo gods that everything works. Okay, so these are 3 tables that we just recreated essentially, and let's move on to our transformations. So for every single transformation, I've included the equivalent from Power Query. So M code that does the same thing as we are doing here in the notebook. And also some notes, like, for example, what is the limitation when it comes to using Dataflow for that particular transformation. So for example, for splitting columns, you must repeat this step for every query that has the same pattern. In a notebook, I can write a function that I can reuse multiple times. And then whenever I have this same pattern across data frames, I can reuse my helper function. So let's first see what we are working with. So I want to show you what's inside of this data frame, in this table, sorry. So I'm reading the data from the bronze orders table. Okay, so you get the idea. This is what we have in the product info column. So essentially, we are going to split the column based on a delimiter. That's the first task. So I will use the split function in PySpark. As easy as that. You see that code is not complicated at all. So basically now we have 3 separate columns for category, subcategory, and product name. Now, the real advantage, of course, I can do this with split for each and every table that I have, but the real advantage is if I encapsulate this logic and then I reuse this logic whenever I need it. So basically what I'm going to do, I will create a function, split pipe column, and then I'll call this function on top of my bronze table. Once it's done, I will save this new table, the one that we cleaned with the function, as a silver orders S1. So this is our first new table that we've created, clean data. So we took the bronze data, we cleaned it with our helper function, and now this clean data is stored in a new table called silver orders S1. Extracting before and after the limiter, again, there is equivalent here, and it's as easy as I will show you now. So what's the idea? We want to extract the carrier name before the limiter. We have this structure here, and there are two approaches. I mean, in data flows, you have this approach that is built inside of the data flow. In PySpark, since it's a, let's say you are writing a code, you can accomplish the same task in multiple different ways. So I will show you a couple of these ways, and then it's up to you to decide which one you want to use. So the first approach is using a combination of the split and get item methods to extract everything before the pipe. So this is the line of code that is doing this. So everything, it starts with a 0. So everything before the limiter, in this case, the pipeline, the pipe is the limiter. Oh, I already executed this. So this is how it looks like. Another approach is to use regular expressions. It's maybe a little more complicated, but it's more robust. So these are results of both approaches. After the limiter, the similar logic. So after the limiter, you just put get item and then number 1. That's the first set of characters after the limiter. This is how it looks like. And orders, number of orders per carrier. Again, you can create a helper function like extract part. So essentially, this one will take the split pattern that I've just shown you and put it inside a function that I can then use across any column I want. So in Dataflow, I need to open every column and then select extract before or extract after. Here, I create a function and I can put it on top of any column that I want. So let's execute that one. And this is how it looks like. The next transformation I want to show you is replacing values. So this is a table. And as you can see, and this is a common case in real life, we have some inconsistencies in the way the data is stored. So for canonical value completed, we have variations with capitalized completed, lowercase completed, uppercase, and so on, or complete, something that looks similar, and similar for other values. What is the main difference and biggest advantage of notebooks? With data flows, you can do one replacement per step. There are no regular expressions, so you can't write regular expressions inside data flow, and there is no bulk mapping. Whereas inside the notebook, I can handle all these variations inside a single cell. So let's first explore what are the values that we need to clean up. So as you can see, I have completed 177 times, then lowercase completed 69 times, and so on. Now there are different approaches to replace these values. The first one is with regular expressions. So this one is more for, let's say, developer first audience. This is how it looks like when we adjust everything. The second approach is using when and otherwise. The combination, if you're coming from SQL world, you're probably familiar with case when expression. So this one is the equivalent inside PySpark. So I will use this approach. It's more readable, more analyst friendly, and I will basically get the same result. So this is the comparison between the original status and clean status. And there is another option, mapping dictionary. Let's run that one as well. So you see, we are getting the same results again. And finally, let's save the output of these cleaned orders using the second approach, the one that is most analyst friendly. So I'll basically write the data from this data frame into a new table called saved as silver orders S3. I see there is a question if you could share a few data sets which we can apply this. Everything is in this. I saw that Leon shared the link to my GitHub account. So if you go there, search for session materials, FabCon Atlanta, and then you can download all of these. So the notebook, full notebook, and all these data sources that are used here for the demo. Okay, let's move on to the next one, which is merging. This is an equivalent to join operation in PySpark and in SQL. When you do a merge in Dataflow Gen2, each merge is a separate query step. Also, you can't easily control some additional settings, some additional configurations when it comes to joining itself, like using joining hints or partitioning strategies. With notebooks, you have a full control, and I'll show you that. So let's first load our 3 tables into, start fresh, loading 3 tables into data frames. So orders, customers, and products. I'll start with a simple left join. So as you can see, it's quite simple. It's join operator. You define the nature of join. So it's a left join and the column where you are performing join. Okay, once I execute this cell, it will join data from orders and customers. I can also add another join on top of this one. So I'm also now adding products. And once I do that, I have the data for orders, customers, and products. You can easily check the output of joins, so validate. And this is very important because for data quality checks, notebooks provide way more options than data flows. So I will validate the join and check if there are any unmatching values between the tables. In Power Query, you can't do that immediately. You can't notice that immediately. So you need to expand the table, check if there are any nulls in these expanded rows, which is, let's be honest, hard to spot. In PySpark, it's, you see 2 lines of code, and then we see that everything looks good. There are no orders with no matching customers and products.
And then Nicola, we just have a question coming in from Fernando. And Fernando asks, the merge join operation is not only similar, but much faster. Is that correct?
It depends. In most cases, yes. In most cases, yes. It depends on the amount of data that you are joining. I mean, so the key difference between data flows and notebooks is that data flows are using a single node architecture. So everything happens, all the transformations happens on a single node, whereas notebooks rely on Spark distributed engine, which has a lot of nodes. So for larger amounts of data, Spark should be more performant because tasks can be split across multiple nodes. But for smaller amounts of data, you need to calculate the overhead of shuffling data between nodes. So sometimes it can happen that for smaller data, data flows work faster. So yeah. So the correct answer is it depends.
As always.
Yes.
Thank you so much, Nicola. Please continue.
No problem. Great question, Fernando. Thanks. Okay, and then let's finally save the output of this transformation into our gold orders table, our first gold table. And I will also show you how many rows and per each category we have. So it's now saving the Delta table. 1,000 records, 5 categories, and this is the total revenue. Appending queries is the similar similar operation, similar transformation to merge. Unlike merge, which is the join equivalent, appending queries is the equivalent of the union operator or stack operator. Again, let's see how it's done inside the notebook. So what I'm going to do in this step is I will include additional file that I've shown you at the beginning, the new orders file, where essentially I want to show you how to append data with and without cleaning duplicates. So just a pure append like union all, and then the union operation that we have. So this is my date range in historical orders. I have 1,000 records. You see the earliest and the latest date. And for the new file, the another file, I have different range of dates, basically. I have some overlapping. So this is the idea to also to include in these comparisons. So simple union, appending all rows without any deduplication. It will show you that earliest we have 1,200 records. So we just appended these new 200 records, and the full date range after appending is from the earliest date that we had until the latest date that we had. Now with deduplication is as easy as calling dedup function. And after deduplication, it appears that we had 50 duplicate records. So once I remove them from the final result, we get 1,150 records. And let's save our unified orders table finally. This is how it looks like. Next section is about pivoting. So that's one of the most common transformations in Power Query, I know. And what I'm going to use here, I have order date in a long format, so one row per each order, and I want to create a pivot table. So one row per category, one column per region, and values should show total revenue. This is Power Query equivalent. Inside PySpark, there is a very easy way to perform pivots. So first, I'm preparing the data. So using loading this long format of the data, idea is to put regions as columns. So there is a pivot method inside PySpark, and you just provide as an argument, you just provide the column that you want to use. So I'm going to provide the category here. Region, sorry, I'm going to provide region, and then I have a region displayed as a column compared to what we had in the original data frame. Now, if you want to additionally improve performance of pivot transformation, then you can specify pivot values explicitly so that Spark knows in advance which values to use. And yeah, this is more or less the same outcome. In this case, we have just one Spark job instead of two. And let's save this as a reporting table for our data analyst. Good. The next one is the opposite. So we did pivoting. Now we are doing unpivoting. I assume the logic is familiar to everyone, so I don't need to explain. This is our wide format. This is my sales wide CSV file. Usually we get data in Excel files displayed like this, and we need to break it down and unpivot so that we get these month and year values displayed as rows instead of columns. So I can do this again in multiple different ways. So Spark has a stack function that performs basically the same thing as unpivot. So this is exactly what I'm expecting to see. And additionally, I can easily clean up month columns so that I extract dates from these columns, and then I end up with something like this. we save this table as gold monthly sales table. Let's move on to the next one, which is uppercase and lowercase transformations. So it's one of the most commonly used transformations in data flows. So let's first explore what we have inside of our tables. So as you can see, I have here different ways of writing names. So Amelia is lowercase, then this one is regular, this one is regular, then I have some values where the first name is okay, last name is uppercase, and so on. So let's fix this. Essentially, there are two functions, lower and upper, and you may assume what each of these functions is doing. So I'm gonna first lowercase everything. In this case, lowercasing emails and handling names to be in title case, so that both first name and last name start with a capital letter. We can also uppercase the values. As I said, it's just the function called upper, which is useful sometimes for some category codes or for key columns. This is how it's going to look like. And let's finally save our clean customers as a new table. So this is a whole set of different steps that we are performing to clean and shape our data inside the lakehouse. Now, trimming white spaces. Trimming white spaces, let's jump into that one. So there are some hidden spaces that exist in our customer table. If you take a thorough look in the full name column, you see that there are some hidden white spaces here or here or here. So the idea is to standardize this and then use these different options of the trim function to remove blank spaces. So there are three flavors of trim function. Trim itself, which removes both leading and trailing white spaces. Then left trim, which removes only leading white spaces, and right trim or R trim, which removes trailing white spaces only. So once I run this, let's look
Hi, Nicola.
at how it looks like.
Running,
Yeah.
if that's okay. We do have a question coming in.
Sure.
Maybe slightly off topic, but we'll go with it. This one comes in from Jorge. They mentioned, should medallion layers coexist in the same workspace? If so, should they also share the same lakehouse for the silver and bronze layers, assuming gold lives in a data warehouse?
Yeah, if you ask this question, if you ask this question 10 people, you will get 11 different answers. So I'll share my opinion. Again, there is no single correct answer here. There are pros and cons of having medallion layers in separate workspaces. Obviously, the main pro is that you can easier control who can access what, and you can easier assign these workspaces to different capacities if needed. But for example, if you are doing CI/CD with deployment pipelines and you have 3 environments and then 3 workspaces for each environment, you easily end up with a lot of workspaces, right? So there are pros and cons. Having everything in the same workspace, that's what I'm doing in most of my client projects. Having both lakehouses in the same workspace, and then it's easier from the CI/CD point of view. And again, when it comes to permissions, you can share the item directly. It's a whole different story. So for me, it's let's say the sweet spot is having them in the same workspace. I also saw people doing like all the layers inside a single items in a different schema. So for example, you have bronze schema, silver schema in the same lakehouse. It can be done, but for me, it's like too tight, I would say. So for me, the sweet spot is somewhere in the middle. having lake houses in the same workspace. Sorry.
Excellent. Thank you very
much. But again, that's my approach. Again, that's my approach.
Of course.
Yeah.
No problem at all. Thank you very much for going through that for us.
Yeah, no problem. So we see how the data looks like after we applied trim transformations. And finally, let's apply the full recipe. So trim and collapsing internal spaces and title case. This is before and this is after. So you see that Amelia's email is now displayed correctly, her name is displayed correctly, and all the other records are displayed correctly. Just to validate that there are no more hidden white spaces. Before we had 31 white spaces, now we have 0. And we finally save this as a new table, silver customer stream. Now incremental loading, that's one of the points where notebooks win all the way against data flows. Why? I have to be honest. So up until a few months ago, data flows were not supporting incremental refresh at all. Now we have an incremental refresh, but how it works inside the data flow is basically that it creates multiple buckets inside of the data, and then it refreshes only the latest bucket. But still, that bucket might have thousands or millions of records, and it will refresh the entire bucket. So you don't have a row level control over the incremental refresh. So the big advantage here is that with PySpark, with notebooks, you have true row level merge statement, no query folding requirements, and full surface area for doing optimization, running optimizations on written delta tables like optimize and vorder. So let's first create a new table, which will be a clean copy of the bronze orders. So I'm just loading data, so I have my bronze orders preserved in the raw state. So there are a couple of approaches for implementing incremental refresh. So first one is watermark pattern, where we just append new records. So we find the watermark value as the max of updated data, updated at for the data that we've already loaded. So for every run of this code, it will load only rows that were updated at that have the value updated at greater than the watermark value. So current watermark in the existing table, it's this one. So 2nd of December, 5 a.m. So I have 198 records that have updated at greater than this one, and these are just 5 of these 198 records. And I will now write this into my existing silver orders incremental table. So I will now add these records to the existing table, so that this table now has 1,198 records, and the new watermark is this one. So whenever I have new records with updated at later than this one or greater than this one, this will be incrementally loaded. So I'm not loading everything. So I'm just appending. This is the key ingredient, mode append. In that case, we preserve the previous structure and we just add new records. Even better than this, true upsert. So upsert means we are inserting and updating records in the same run. So we don't do two separate transactions, two separate operations. We are doing everything in the same hop. And basically, PySpark natively supports merge operator. And this is the condition column that we want to do a merge operation, is this one, order ID, from the source and target. My target is the existing table. My source is the new data that is incoming. So I'll now show you how this looks like with merge. We have 200 records. Before merge, we have the value from the previous run. And after merge, we have 1,200 records. So we loaded 2 additional records or updated compared to the previous run. And if I want to verify the merge, So to find which records were updated. So sample of records that were updated, those are status changes from orders new file, from the file that we are using. And you can see that it shows the updated from this new file. Another cool feature that we have inside of notebooks is that we can follow the table history. So everything that's been done on that table, you can't do that obviously with data flows. Inside the notebook, you can run the command describe history, provide the table name, and then it will show you all the operations that were applied on that particular table, including all the details like what's been changed and so on. So you can see that today at 17:43, I created this table. Then I wrote some records inside of it. Remember our incremental load, 198 records. And then I did a merge on this table, and it shows me the number of rows that were deleted, files added, and so on and so on. So it gives you a lot more insight into the history of the table and which changes have been applied previously to that particular table. Let me go back quickly to the presentation. So we already saw this inside the demo. Now I want to show you a couple of things and couple of techniques that really push your experience as a data analyst, data engineer to a whole new level. Talking about performance, 4 specific optimization techniques that every notebook user should know. Those are V-order, optimize, caching, and broadcast joins. So let's quickly introduce each of them, and again I will show you in a demo how they work. So V-order, I don't want to bother you too much with technical details. Think of it as a write time optimization for Parquet files. It applies some kind of Vertipack compatible sorting and compression so that downstream engines can read the data faster. The impact is different depending on the engine. Obviously, Power BI Direct Lake sees the biggest benefit because it's based on Vertipack. So 40 to 60% faster cold cache queries. SQL Analytics endpoint gets about approximately 10% read improvement. These are average values, so don't take this for granted. There will be some exceptions here and there. Spark itself doesn't directly benefit from V-orders encoding, but optimize the optimize command that I will show you next will help in consolidating smaller files. What is important to know, V-order is disabled by default in Fabric workspaces created after April 2025. I know it sounds like a beginning of some strange horror movie, but that's how Microsoft decided all of a sudden last year in April for all the workspaces that were created before April 2025. Default behavior when you use notebooks is that V-order was enabled. After workspaces, for all the workspaces created after April 2025, V-order is by default disabled, just for notebooks. So if you are using data flows or if you are using warehouse, V-order is still by default enabled. This is true just for Spark, okay? But there are some enhancements. So they introduced so-called resource profiles, which you can use depending on the workload. So if you change the resource profile from the default one, which is write heavy and which has V-order disabled, if you change it to read optimized, then it will automatically apply V-ordering. Essentially, to cut the story short, V-order is you pay the price when you are writing the data into Fabric, but you will probably see a big benefit, especially if you're using Direct Lake storage mode for your Power BI report. So longer data writes, faster data reads, to cut the story short about V-orders. So 4 tools in your optimization toolkit. Top left corner, V-order plus optimize. So always run this after significant loads. top right is Optimize alone for bin compaction. So Optimize, what Optimize is doing, it merges, it compacts small Parquet files into larger ones, targeting between 128 megabytes and 1 gigabytes. And don't forget vacuum command to reclaim old unreferenced files. In the bottom left corner, it's data frame caching. So you can pin the dimension table into Spark memory if you're reading it multiple times in one notebook run. And then also broadcast joins. If you're joining a large fact table to a small dimension table, broadcast the small one to every executor. This eliminates the shuffle step completely. What's the idea? I don't want you to remember by heart all of these optimization techniques, but what's the general idea behind this is that you have options to optimize your workloads when you're using notebooks. You don't have these options in data flows. In data flows, when it comes to optimization, you are locked. So whatever is implemented inside the data flow when it comes to performance, it's a black box for you as a developer, whereas in notebooks, you have mechanisms to enforce certain optimization techniques. Just to show you a couple of these examples in the notebook. So as I said, none of these are available except vOrder, which will be enabled by default. So in case you want to disable it, you can't do that. So by default, Dataflow writes with vOrder enabled. Caching has no equivalent. Optimize blocked for incremental refresh table. And I would argue that this is the biggest performance gap between data flows and notebooks. So first, let's check the current vOrder setting. Currently, it's enabled. Okay. And then I can control this on the session level, or I can set vOrder permanently on a specific table. So these are the options that I have. I have very granular control over how vOrder will be implemented. I can apply this retroactively with optimize command. If you're coming from Databricks world, you may have used zorder. That's also supported in Fabric. Optimize command after every big important append or merge operation for high frequency loads, it makes sense to run optimize to compress small Parquet files into one bigger file. In this case, doesn't show any benefit because we have a very small table, which is like 66 kilobytes, and it's just one file. But in reality, you will have tables that consists of hundreds of small files, and in those cases, optimize is a real performance champion. You can also run optimize and vOrder in one command. Vacuum is removing unreferenced files. That's also something which you can control with notebooks, and you can't control with data flows, because by default, when you write the data with data flows, it will be 7 days period. With notebooks, you can change this default setting. Now, since we are almost on time, I will skip some of these notebook cells. I'll leave it to you to download this notebook and play around. A few closing words before we check if there are any additional questions. So the destinations, where can each tool write? We talked about Dataflow Gen2, but there are still a lot of people out there using Dataflow Gen1. Nowhere persistently, but I won't spend time because they are being deprecated anyway. So Dataflow Gen2 can write into Lakehouse, Warehouse, SQL database, and SharePoint. I'm not sure if they added something in the meantime. Notebooks will mainly write in the Lakehouse, although you can also store data as files. There are certain drivers that you can use to connect to databases, and you can do essentially anything that Python can do. You can do inside the notebook. For incremental loading, I already explained how it works and why notebooks are the winner here, absolutely, with full control. Some of the key takeaways, I have 5 of them. first, your M skills translate directly. So split, remember the split function in PySpark is the same concept as splitter in Power Query, when otherwise is conditional column. Same logic, just a different syntax. Reusable functions beat repeated steps. Remember when we created these helper functions for extracting text before and after the limiter. So one PySpark function replaces a dozen data flow steps, and it's version controlled, it's testable, and it's shareable across any notebook. Number 3 is Dataflow Gen2 incremental refresh is real thing, but it's very limited. So bucket replace requires query folding, blocks optimize, and can't do row level upserts. Delta merge gives you a full control on top of this. Number 4, V-order is your first optimization always, especially when you need to use this data for fast data reading operations like Power BI Direct Lake. And I think maybe this is most important. This transition from data analyst to data engineer is not something that can happen from after watching this session and then tomorrow morning you wake up as a data engineer. It's gradual and it's not all or nothing. So keep data flows for simple low code ingestion and transformation. Reach for notebooks when you need incrementals, when you need merge, when you need performance control or code reusability. With that being said, that's all I had to show you in this session today. Let me just, sorry about that. And let's see if there are any other questions.
Absolutely, Nikola. And obviously fantastic session and well done. Kudos for getting through all of that in under an hour. Absolutely fantastic roadmap.
I did my best. Maybe it was too fast, but I did my best.
Lots of golden nuggets in there, and I would recommend to anybody to go to the GitHub, which we have shared the link, and obviously to re-watch this session following as well. But we do have some questions, Nikola. I'll pick a couple, obviously just in regards to the time as well. So I think an interesting one probably to cover off would be this one from Ellie Belly. I'd also like to know, actually, sorry, let's go to this one first, if that's okay. So this one's actually from Jantikal. So this one is 4 Fabric notebooks. Are PySpark and Spark SQL the same under the hood for performance cost, just a different language? How does this compare with a SQL first approach, such as for DBT in Fabric?
Yeah. So to answer the first part of the question, yes, they are the same. They are just different wrappers under this around the same thing. Spark is written in Scala, so both Python and SQL are just wrappers around it. So yeah, there shouldn't be a big difference in performance or cost. How does this compare with a SQL first approach such as DBT Fabric? Yeah, depends on what you are trying to achieve and what you currently have. So if you are already using DBT, then probably it makes more sense to continue using DBT because it integrates with Fabric. Otherwise, if you are starting greenfield, I would rather go Spark SQL route. If you're talking about SQL first approach, I would rather go either Spark SQL or Transact SQL route in Fabric.
Excellent. Thank you very much, Nikola. And then we'll just jump back to this question from Ellie Belly. This really looks at the use of PySpark functions and learning more about it. And typically they ask, is this a mix of SQL?
No, it's not. So PySpark is essentially a dialect of Python. So it's a Python language which is adapted to support the way the Spark works. It also has Spark SQL, which is more kind of a ANSI SQL that we know. M is completely different. M is a completely different language, different syntax, so it doesn't have anything in common with PySpark.
Excellent. Thanks for clearing that up, Nikola. And there were some links into the PySpark documentation posted into the chat as well. So that's all the questions we're going to have time for today, Nikola. What I'll do is I'll just bring on screen a couple of comments as well. So Fernando mentioned this session's pure gold. Much appreciated.
Oh, thank you. appreciate that. Thank you.
That he's a convert to data engineering now, which is absolutely great. We have some more comments coming in. Great session. Thank you. Perfect session. And thank you
everyone.
Much, Nicola. So very widely well received. And as I've mentioned, Nicola, absolutely fantastic job of covering off that topic. Very in-depth in that time period.
Thanks everyone. Thank you everyone, and thanks to you, Leon. Yeah, from my side, a couple of closing words. Yeah, thanks for joining. Thanks for these kind words. I encourage everyone to download these materials and to play around and see. I mean, the key takeaway is that this transition is not so huge as it might look, right? Because nowadays with the agents and the AI, writing the code itself is that became the smallest problem, right? So this notebook that I'm sharing was fully generated by AI. Of course, I give it an overview and checks that everything works as expected, that there are no some nonsenses there. But what I wanted to encourage you is literally what I did. I took M code and asked agents to generate PySpark equivalent. So if I could do that, you can also do that. So that's what I wanted. That's one of the big, the key messages here. Don't be afraid of jumping into notebooks if you never coded before.
Absolutely, great share there, Nicola. Thank you very much for that. And thank you everybody everywhere in the world for joining us at the Microsoft Fabric UK user group. You could have been anywhere in the world, but you've been here with us. Take care.
Thanks, Leon. Thanks for having me, and greetings to Pragati. We missed her.
Thank you.